Okay, are you on page 22? Put your finger on it. And I just want to let you know that we are essentially going to do the exact same thing that the quadratic formula was out to do, which is what? Finding the x-intercepts, which are also called roots, which are also called zeros, which are called the solutions of the quadratic. Doing the exact same thing. So the graphing method of solving, right? It's still doing the same thing here. We're finding the x-intercepts if possible. Note that if lines do not touch, there's no x-intercept. So you've got two options for using the graphing method to solve a quadratic. Option 1, always let y equals to 0 if present. So that I'm always going to state that, just like before already with the quadratic formula. You rewrite the equation in general form. So what I mean is bring everything to one side. That's what I mean by going into general form. Yeah. Bring everything over to one side, then enter the left-hand side, that's what LHS means, okay, into Y1, and the right-hand side into Y2. Then you go second trace 5 to find any and all x-intercepts. Okay, you've been doing that already up in this point, okay? Then option number 2, same thing, you let y equals to 0 if present, enter the left-hand side into Y1, right-hand side into Y2, and this is what I want you to highlight. There's no rewriting necessary using this method. That's what I like it. I like this one the most out of the two. I'm not going to force you to do one or the other. You choose. Okay? And another thing important here, you must answer with a number followed by a 0, because remember, we're finding the x-intercepts. So here we go. I'm going to do option 1 and option 2 side by side. Okay, so follow me here. Solve the following using a, what does it say? A graphing method. So if I told you you solve the following using a quadratic formula, you use a quadratic formula. If I say graphing method, page 22, use graphing method, which we're about to do here. So option 1. Rewrite. Okay, this one involves rewriting. So it's a little bit more work. So I'm going to rewrite the, I'm going to actually copy the exact same thing down again. And I did make it look a little busier than normal. But that shouldn't affect our strategy. So let's clean it up. So I'm going to have a red pen in there to show you the steps that I'm taking. I would first get rid of any brackets here. So multiply, multiply, multiply. And so you distribute that to, so let's do that as our next step. 32x squared minus 15x plus 50. 2 times 6x squared is 12x squared. 2 times 125 is 250. 2 times 75 is 150. And now I will choose to bring everything over to this side, okay? So 32x squared is going to be followed by the 12x squared, which is now negative. Then the 15x is going to, oh, I forgot the x here next to the 250, folks. It's supposed to be an x right there. Please remember that. So the 15x here is going to be accompanied by the 250, which comes over subtracting. Okay. then the 50 that's already on the left-hand side is going to be accompanied by the 150, but it's going to be negative 150 because when it comes over the equal sign, it changes signs. Okay, so now I combine my like terms. Okay, so 32 minus 12 is 20x squared positive. Negative 15 and negative 250, that would be negative 265x. Plus 50 minus 150 is negative 100, is equal to 0. So don't use your quadratic formula. You could if you wanted to, but right now we're doing graphing. So basically, I take the left-hand side. This is how you show your work. You put this into y1, and you put this into y2. And you're going to go second, trace, intersect. So let's go ahead and see if we can make this appear on our graph, because that is also a challenging part of this whole operation. So we go to y equals, turn off plot 1, you're not doing a regression, and then go and type this into y1. So 20x squared minus 265x minus 100. And the right-hand side goes into y2, which is 0, right? It's 0 for us. So that's what I do there. And let's hit graph when you're ready. Probably not going to see it. Oh, I do see something. I will use zoom fit if I can. Okay. Actually, let's do zoom standard first, then zoom fit. It seems to work better that way. Zoom standard kind of gets you to the origin. And then we're going to go zoom fit, which is option 0, right? Right there, 0. Hit that. So we want to find the intersections between the red and the blue. It's showing me the one intersection here, but I need to see the one on the right side here. So what do I need to change on the window? X max, yeah. I'm going to go 30. Let's see if that works. Perfect. I see both intersections. That's all I want. The x-intercepts, I should say. Second, trace 5. Pick which one you want. I'm going to go closer to the left one there. Enter, enter, enter. So your first solution is negative 0.370. And your second one is, bring it all the way over. You got to go second trace, intersect again. Enter, enter, enter. And there it is, 13.620. Oops. 13.620. Now, we're going to cut it right here. Should have maybe given you a heads up to leave space on the right side. But this is option 2. I'm going to copy down the original here. And this is how, in my opinion, this is less work and less of a chance of you making a mistake along the road. So I'm going to say you take left-hand side as is, you put that into y1, and you take the right-hand side as is, you put that into y2. And then we're going to go second, trace, intersect, and find the intersections. The challenge is going to be seeing them on the graph, but zoom fit is often really good at finding that perfect window. So let's clear everything into our y's. So type in exactly the way you see it there. That's the first one. Second one, 2 bracket 6x squared plus 125x plus 75. And that's a graph. By the way, let's look at, this is a parabola, correct? This is a quadratic on the left-hand side, and the right-hand side is also a quadratic. So you're graphing 2 parabolas, okay? That's a graph. Oh, it actually does a pretty good job. Basically, we're going to find the intersection between the blue and the red here, and we also need to find the intersection up here where they meet again. So I'm going to increase my y max here. So I'm going to go to y max and change that to, I don't know, let's say 7,500, because it's already a big number. There we go. So we see that they meet at 2 places. So there are 2 solutions, 2 roots for this quadratic equation. So we're going to go second trace 5. Let's go to the first one here, this one. Just hit enter 3 times. And watch what it does. Right, that's the coordinate of the first one. The second one, second trace 5 again. I'm going to go closer to that one. Hit enter 3 times. That's 13.62, 5,779.43. Now, do you notice that the x values are exactly the same, right? Negative 0.37, negative 0.37, and 1362 and 1362 matches, right? So the only thing that you have to account for if you do it this way, make sure you get this part, is you got to ignore this one. You got to ignore those y coordinates and just state them as 0, okay? So negative 0.370, and this is 13.620, okay? Ignore y coordinates. That is one big if you do option 2. So on your study sheet, you should have solving quadratics. I'll let you finish copying this. In my study sheet, I would have solving quadratics. There's a quadratic formula. There's the graphing method. And you might want to choose which option you'd like for your graphing method. I would say the risk with using option 1 is if you rewrite it, that you make a mistake in rewriting it. So then you'll lose marks there. So if you just keep it as is and you just type it in, I would say here, zoom fit, right? Zoom fit is your friend with either one, actually. Zoom fit is always there for you. It's a tool. Use it if you must, okay? All right. I'm going to ask you to practice pages all the way to 25. And it does ask you sometimes to use the quadratic formula to verify, okay? So try that.